Hello and welcome to this video on adding and subtracting rational expressions with unlike denominators. This is piggybacking off the previous couple videos I've made where in one video I was just adding fractions with unlike denominators, and in the other video I was subtracting fractions with unlike denominators. So this is just a video where I'm doing a couple examples, a much shorter one, where there are three fractions and I am both adding and subtracting in the same problem. The steps are the same. Find the LCD, rewrite each fraction with that LCD as its denominator, as an equivalent fraction with the LCD, and then add, subtract, and then simplify. Make sure the numerator and denominator have no common factors. Alright, so begin. My first example, I'm going to perform, so I'm just simply asked to perform the indicated operations. Alright, you see I'm doing addition and subtraction here, right? We're taking this fraction, 1 over x plus 1, minus this fraction, 2 over x squared minus 1, and then addition, right? After, and if you remember your order of operations, when you do addition and subtraction, right, you do it from left to right as you see them. So we're going to subtract these two first and then add this fraction to them, the 3 over x minus 1. Alright, so as I mentioned at the title screen, I'm performing the same steps in the previous videos where I was just simply adding or just simply subtracting fractions. So first is, I'm going to find the least common denominator, right, the LCD, or the least common multiple of the denominators. Alright, so in order to do that, I'm going to factor all the denominators completely. So we're only focusing on the denominator. So x plus 1, it's a polynomial with two terms. The GCF, the greatest common factor of these two terms, is 1. So there's nothing to do here. This is already completely factored. So if you want to say all of this, right, in parentheses, this polynomial with two terms, this quantity x plus 1, this is the only factor of x plus 1. The next denominator, x squared minus 1. This is one of those differences of two squares, right? X squared minus 1 squared. And that would factor to x plus 1 as one factor times the quantity x minus 1 as the other factor. And again, you can double check by multiplying these, distribute the x, distribute the 1, combine like terms, and you should get x squared minus 1. And the last denominator, right, so I'm looking at all the denominators here, x minus 1. Again, like x plus 1, the greatest common factor of these terms is 1, and there's really nothing to do here. The only factor of that polynomial is x minus 1, and 1, but 1 is a factor of anything, so I don't really consider it. Alright, so now that I have the factorizations of each of the denominators, we can now state what the LCD is, the least common denominator, right, or the least common multiple of the denominators. So the factorization of the LCD is made up of factors that show up in at least once in the factorizations of all the denominators. So I'm looking through these denominators here. I'm seeing a factor of x minus 1 showing up. So there's going to be x minus 1, at least one of these, and then we're going to raise it to some power in the factorization of the LCD. Times, and then again I'm going through the factorizations of these denominators. I'm seeing factors of x plus 1. So I'm going to have a x plus 1 to some power in the factorization of the LCD. And what are those powers? What are the exponents on these factors of x minus 1 and x plus 1? And it's just what's the largest number of times that factor appears in any factorization of the denominators. So x minus 1 shows up 0 times here, once here, once here, right? And the largest of 0, 1, and 1 is 1. So you have x minus 1 to the first, or just simply x minus 1, right? There's really no need to write to the first power. It doesn't do anything, change the value. The same thing for x plus 1. This factor of x plus 1 shows up once in this factorization, once in this factorization, and 0 times in this. And the largest of 1, 1, and 0 is 1. Okay, so the LCD is x minus 1 times x plus 1, or if you'd like to write that out, that's x squared minus 1. But I'm going to leave things, I like to have my denominators factored. If you've seen my previous videos as well on adding and subtracting, you know that I like to keep the denominators factored, because it'll just make simplifying at the end that much easier when we go to find what are common factors of the numerator and denominator after the addition and subtraction. Alright, so part 2. Alright, so first was find the LCD, and then I'm going to rewrite equivalent fractions. Alright, so I'm going to take all 3 of these fractions here and rewrite them as equivalent fractions with the LCD, with this x minus 1 times x plus 1, or x squared minus 1 as the denominator instead, right? Because if you look at all the denominators right now, they're different. You cannot add or subtract when the denominators are different, right? The only way you can add or subtract is when denominators are the same. You have a common denominator, so that's what we're trying to do here. So we're going to rewrite equivalent fractions, and I'll just say with the LCD. Alright, so that just means with that denominator, this as the new denominator. Alright, so I'll take these one at a time. So we have 1 over x plus 1, the first fraction. And in order to change a fraction to an equivalent fraction, you're going to multiply by 1. Now, when I say multiply by 1, we're going to multiply by a fraction that's equivalent to 1, meaning I'm going to multiply by the same number or expression in the numerator as I do in the denominator. Right. So if you look at x plus 1, that's totally factored. Right? Like my denominator is factored. What do I need to multiply it by to make it look like the LCD? Well, it's got x plus 1. It's got this factor of x plus 1, and it's got multiple terms, so I'll put in parentheses here. It's got this factor of x plus 1. It's missing the factor of the quantity x minus 1. And same thing for the numerator. So that way, again, it's like I'm multiplying by 1, right? X minus 1 divided by x minus 1 is 1. As long as x is not 1, right? You can't divide by 0. Alright, so in the multiplication now, we get this equivalent fraction. So that fraction I started with, 1 over x plus 1, right, is equivalent to, now 1 times x minus 1, anything times 1 itself is just x minus 1. Okay. Over, or divided by, and then the LCD, right, x plus 1 times x minus 1. Again, I like to leave my denominators factored. Not the numerators so much. Right? The numerators I'll wait until the very end when we put them all together, make a single fraction, and then I'll factor the numerator, and we'll see if we can simplify the fraction any further. Alright, so I'm going to change this fraction to that. The fraction being subtracted from that is 2 over, and again I like to have my denominators factored, so instead of the denominator of x squared minus 1, I'm going to write that as x plus 1 times x minus 1. And, oh look, that denominator is the LCD, right? And again, it doesn't matter what order factors in a product come in when you're dealing with real numbers, which we are here. So this is great. So I'm done. All right, so I'm going to leave that the way it is, but again, I'm just going to rewrite the denominator factored. The third fraction, right, the one being added after the first subtraction, 3 over x minus 1. again, I'll put that in parentheses because that's the only factor in the denominator. I'm going to again multiply this by 1, right, and the numerator and denominator by the same thing, and make it the LCD, give everybody the same denominator. Well, it's got a factor of x minus 1 in the denominator already, so it's only missing this x plus 1. So I'll multiply by the factor of the quantity x plus 1, and same to the numerator. All right. And we get our equivalent fraction. Right. So the denominator is this LCD, right? And I'm going to write it in the same order, the factors in the same order, just to be consistent. So we have x plus 1 times the quantity x minus 1. The numerator, again, you're multiplying by this entire x plus 1, so you're going to be distributing the 3, right? Not just multiplying 3 by x, but by the whole thing, x plus 1. So you have 3 times x, 3x, plus, and then 3 times 1, 3. So that's the new numerator of the fraction that's equivalent to 3 over x minus 1. Alright, great. So I'm going to take this to another page where we rewrite our original problem with all these equivalent fractions. Alright, so I'm going to take this down here. And we have, 1 over x plus 1 is now this fraction, so x minus 1 over, and then x plus 1 times x minus 1. Okay, and then we got minus, let me scoot this up a bit. You saw that, right? That's still there. You can back the video up if you want to see that again. Minus, and then this fraction is not changing. Right? The only thing I did change was I factored the denominator, right? So it's still 2 in the numerator over, and then the denominator is again x plus 1 times x minus 1. Alright, and then plus, and then this fraction here, right, was equivalent to this one here, right? The last one, 3 over x minus 1, we changed to 3x plus 3 over, and then the same denominator, that LCD, x plus 1 times x minus 1. Alright, wonderful. So now that they all have the same denominator, alright, now they all have the same denominator, I can combine them. Alright, I can add them together. And remember, when you add or subtract and the denominators are the same, that common denominator stays the denominator, right? You do not add or subtract the denominators. The only things you combine are the numerators. Alright, so now remembering order operations, right? You do things in parentheses first, which I'm not seeing here. I mean, I'm seeing parentheses, but there's nothing to do. These are just factors. Do things in grouping symbols first. Then simplify anything with an exponent, which I'm again not seeing here. No power, nothing raised to powers. No multiplication or division of these guys, right? I mean, yes, there are multiplications here, but I'm not going to worry about that right now. But then, when you do it, in the last part, when you do addition and subtraction, you do them in order, from left to right. Go from left to right, doing them as you see them. All right, so I see the first operation I'm seeing here is this subtraction, so I'm going to do 2 at a time. Right? So we have this fraction minus this fraction. All right, they have the same denominator. So that's still going to be the denominator, the x plus 1 times x minus 1. It's the numerators we're combining. Alright, so remember now, if I've done this in previous videos, when an expression has multiple terms, like this one has 2 terms, x and -1, I like to put it in parentheses, right? You're taking that whole first numerator and then subtracting from that the whole second numerator, 2. And the second, that one has 1 term, so I don't put parentheses around it. Not really necessary. And you might have argued that it's not necessary for the parentheses here because it's not being multiplied by anything. There's nothing to distribute, and it's not being raised to any powers, which would be valid. I mean, you can say that there's no need for parentheses there. All right, and then and then simplifying this, x minus 1 minus 2 is x minus 3. Alright, so when I subtract these two fractions, I'm getting x minus 3 in the numerator, and then the x plus 1 times x minus 1 in the denominator. Alright, and then don't forget this now. Alright, so that's just subtracting these two, the first two. And then all this I'm going to drop down. Okay, that's a pretty faint marker. It's going to go in the trash. And then we have plus this fraction, plus the 3x plus 3 divided by, and then the x plus 1 times x minus 1, the LCD. Alright, so now, I'm going to go over here. Fraction plus fraction, the denominators are the same, and once the denominators are the same, you can put them together. And the denominator of the sum will be that LCD, that common denominator, so x plus 1 times x minus 1. And then I'm adding the numerators. So the numerator of the sum is this first numerator. Again, it's got multiple terms, so I'm going to put it in parentheses, even though it might not be necessary sometimes, but sometimes it is, especially when subtracting, so be careful. So this first numerator, x minus 3, plus, then this second numerator, again, has multiple terms, so I'm going to put it in a group, put it in parentheses, 3x plus 3, and great. Here is the final result, before we simplify. Alright, we're going to get into simplifying in a second here. But this, if you go back to our original problem, right, so here was the original statement. So this fraction, the value of minus the value of this fraction plus the value of this fraction will be equal to the value of this single fraction I have here. Okay, but it's not, it's not completely simplified. So we're going to keep going. We can combine some like terms in the numerator. You see I have 1x there plus 3x there. That's 4 x's. When you combine the like terms with the x's. And here I have negative 3 plus positive 3. Negative 3 plus 3 is nothing, 0. So the only term left over in the numerator is 4 times x. It's got a couple factors now in the numerator, 4 times x. And in the denominator, still the x plus 1 times x minus 1. All right. And this is great. So my original problem, let me sorry about this, pulling this away, I'm going to fold some stuff down so we can put it with the original. So back to the original problem here. All right, this fraction minus this fraction plus this fraction will have the same value as this one here. And if you want to multiply the bottom out, make this 4x divided by x squared minus 1, that's fine. Now, it's not always the case that they're the same. All right? So off to the side, again, if you've seen previous videos of mine, I like to keep track of this. Remember, you can never divide by 0. You can never have a denominator of 0 or a factor of 0 in the denominator. That'll make your denominator 0. Dividing by 0 is undefined. Has no meaning. So this plus minus this plus this will be equal to this as long as denominators are not 0. So as long as the value I replace x with is not, well, let's see, look at the denominators here. Throughout the entire problem, I saw factors of x plus 1, right? X plus 1, factor of x plus 1, x plus 1. I see factors of x plus 1 in my denominators. So x cannot be negative 1, right? Because if x were replaced by negative 1, this denominator would be 0, that denominator would be 0. There'd be denominators of 0 throughout this problem. So that's no good. And then the other way around, and the other ones, the only other factor I've seen is x minus 1, right? Throughout this entire problem, I see factors of x plus 1 and factors of x minus 1 showing up in my denominators. So the value of x cannot be replaced by positive 1 either. Because if you replace x with positive 1, you'll be dividing by 0 in a lot of places in this problem, and that is no good. So here we go. This is our final result. The numerator and denominator have no common factor, so this is a simplified fraction, right? There's no x factor of x down here. Yes, there are x's, but there's no factor of just times x down here. There's no factors of 2 or 4, right, down here. So this is simplified, and this minus this plus this will be equal to this, as long as you don't replace x with -1 or 1. And let's test that out. Let's test that out. Let me try to plug in a value for x that's not -1 and 1. See what this minus this plus this equals, and then let's see what this equals, and hopefully they're the same, and they should be, right, if I did everything correctly. Well, a number that's not -1 or 1 is 0. How about 0? And again, plug in whatever you want, as long as it's not these two. Plug in 2, 5, a million, -5, -3/5, whatever you want, as long as it's not these two. Alright, let's try 0 for x. Now, if I plug in 0 for x, this fraction would just have a value of 1. It would be 1 divided by 1, 0 plus 1. Minus, this would have a value of -2, so minus, -2. 2 divided by -1, right? 0 minus 1. And then plus, and then 3 divided by -1, or -3. Okay. Well, 1 minus -2, that'd be 1 plus 2. So this is 3. And then plus -3 is the same as minus 3. We're getting 0. So this minus this plus this. When x is 0, this whole expression has a value of 0. Well, let's try it in the other, and what we said it was equal to, this guy here. Well, you see how the numerator would be 0, right? Because you got 4 times 0, so the numerator is 0. The denominator would be 1 times -1. And so I'm getting 0 divided by -1. Well, remember, 0 divided by any non-zero number is 0. So yes, it works. The value of this expression is indeed the value of my fraction here when x is 0. And you will see that that is the case whatever you plug in for x. Try it out with a few others, as long as it's not -1 or 1, and you'll see that the value of this, whatever it is equal to the value of this. Great. Alright, so I have one last example of this where I'm doing some addition and subtraction in the same problem. But this time there are a group of parentheses. Alright, so remember what that means. So remember, in a group of parentheses, I'm going to be combining these first. Now you could distribute the -1, out here. Whenever you see a minus sign, technically it's like having a factor of -1. So you could take this as -1 times all this and then distribute it. But I'm going to stick to our order of operations for expressions, and we'll simplify what's inside grouping symbols first. So I'm going to do this first. So we're going to take the expression in the parentheses here, and we're going to simplify first. Or I'll put those together as a single fraction first, and then we'll subtract that from 3 divided by x. Alright, well, before I get in any of that, LCD. Alright, so I'm going to go try to find the LCD. So look at the denominators. Right, the first denominator of all the I'll do all the fractions. The first denominator is x. Well, that's it. That's the only factor. And it's only got one term, so I'm not going to put it in parentheses. But so the factorization of x is x. X minus 2, this other denominator. Again, now this time this has multiple terms. So I look for greatest common factor, which would be 1. So this doesn't factor any further either. And again, I'll put this in parentheses just because it has multiple terms. But there's the factorization of x minus 2. It's just simply the one factor, x minus 2. And the other denominator, x squared minus 2x. Now this one, look at the two terms. What do they have in as a common factor is x. So I factor x out. So you have x times, and then another factor. When I remove the factor of x, what's left over would be x minus 2. Okay. So the least common denominator, right, the factorization of the least common denominator, Looking through all these factorizations, I see factors of x, so you're going to have x to some power in the factorization of the LCD, times, and then I'm also seeing factors of x minus 2 in here, so you're going to have x minus 2 to some power in the LCD. And remember, the powers on these factors are just the greatest number of times that factor appears in any of the factorizations of the denominators. So x appears once, 0 times, once. So 1, 0, 1, x to the first, x to the 1. Not going to write that. And then x minus 2, this factor, appears once, 0 times. So again, 1, 1, 0. The largest of those numbers is 1. X minus 2 of the first, or just the quantity x minus 2 is a factor of the LCD. Alright, so now that I have the least common denominator, I'm going to rewrite these fractions. So 3 over x. Right, 3 over x. We're going to multiply this by 1, right? So I'm going to multiply the numerator and denominator by the same thing, so that the denominator is now going to be this LCD. Well, it's got the factor of x in the denominator already, only missing this x minus 2. Alright, so I multiply by the factor x minus 2, in parentheses the whole thing. Same thing here in the numerator, quantity x minus 2. And I'm going to keep, right, I like to keep my denominators factored until the end. So the denominator is the LCD, right? X times x minus 2, or x squared minus 2x, but again, I'll leave it factored. The numerator, though, I'm going to actually multiply out. We're going to distribute that 3. Got 3x minus 6. All right. 3 times x minus 3 times 2. Great. Then the fraction here, 1 over x minus 2. And the denominator has multiple terms, so that's the only factor in the denominator. I'm going to multiply this by 1, right? So the LCD is in the denominator now. It's got a factor of x minus 2, so it's only missing x from the LCD. So I multiply by x in the denominator and x in the numerator. So the numerator is just 1 times x, or x, and the denominator is, again, I like to reorder it so we stay consistent, is the LCD x times x minus 2. And then this third fraction that I'm seeing here, the 6 over x squared minus 2x. Again, I'm going to write this factored. X squared minus 2x we saw was x times x minus 2 over there on the right side of the page. And this already has the LCD as a denominator. They're all the same denominator now. So I don't need to do anything here. Alright, this fraction's good. Alright, so just like last one, I'm going to take this to the following page. Take this to a new page. And we're going to write these 3 fractions as these equivalent fractions. Alright. So my first one was, 3 over x. Right? Let's look back at the original. 3 over x. So 3 over x became, 3x minus 6 over the LCD x times x minus 2. Minus, and then big set of parentheses here are brackets. This fraction, 1 over x minus 2, that became x over x times x minus 2. And then we have minus again in here inside the parentheses, right? We got minus. And then this fraction is good, right? It has the it has the LCD as the denominator already. I'm just going to write that in factored form though. So 6 over, or 6 divided by, and then x times x minus 2. And then close the big set of parentheses there. Alright, so great. The first step's done. First couple steps are done, right? I found the LCD. I rewrote every fraction with that LCD as a denominator. Now I'm going to perform the order of operations, and we'll put these together. Alright, so this is really just going to involve a bunch of subtraction. Alright, so you got... We're going to combine these two first. Alright, go inside parentheses first. We'll put these, make these into 2 fractions into 1 fraction. Alright, that's what happens whenever you add or subtract. You take 2 things and make it into 1 thing. Okay, so I have this is just going to drop down. I'm going to leave, we got 3x minus 6 over x times x minus 2 minus, and then these two become 1, right? And as with anything, like with polynomials and stuff, when it's two terms, and I got in parentheses, I like to keep it that way. But when it's just one term or a single fraction, no need for parentheses. I mean, you could put a big set of parentheses here, but we're just going to make this a single fraction. So when I put these together, right, they've got the same denominator, so that's going to stay, right? X times x minus 2 will still be the denominator. And then I'm combining the numerators. Now the numerators of these both have a single term, so I'm not going to put parentheses around them. So it's just x minus 6 will be the numerator in the difference, right? All right, great. So now I've made these two into 1. No need for the parentheses anymore, right? You just have a single fraction. And now, again, I'm not done. I want to put all these together as a single fraction. So now we're taking this first fraction minus this second one. Go over here. Common denominator, right? They have the same denominator already. We already set that up. So the result, the difference between these two is going to have that same denominator, right? X times x minus 2. And, it's the numerators we're combining. Now, each of these numerators has multiple terms. So we got, the quantity 3x minus 6, right? The first numerator, minus, and then the quantity x minus 6, right? The second numerator. And be aware that you must put the parentheses around these two terms. Because you're not just subtracting, when you're subtracting this fraction here, you're not just subtracting the first term, just the x. You're subtracting this entire numerator from that entire numerator. So that's why I'm putting it in parentheses, and hopefully you can see that we're going to be distributing like a -1, right? Remember, I've mentioned this before. If you ever see a minus sign, that really implies that you have a factor of -1. It's like times -1. So this is like -1 times x minus 6. Same thing when I see minus 2. That's like plus -2, -1 times 2. So I'm distributing the -1 to this x minus 6. You are subtracting both terms from that numerator. So just be careful with that. Alright, so we have 3x minus x, so 2x, right? And then -6 minus -6, right? -6 minus -6, that'd be minus -6 would be plus 6. So -6 plus 6 is 0. So the only term I have left up in the numerator is this 2 times x. And now I have it's a couple factors now. It's a product. 2 and x are factors of the numerator. And the denominator is still x times x minus 2. And I'm almost done. Now we say, hey, I got it as a single fraction. Fantastic. If you go back to the original, this fraction minus the difference in these two fractions is going to be equal to this fraction here. Is it totally simplified, right? We combine like terms in the numerator, right? Got our denominator factored. Now here's where I factor the numerator, which it's already done. 2 times x, can't break that down anymore. Factor the denominator, already done. I've left it factored for a reason. And then you cancel common factors, which I am seeing a common factor of x. Right, there's x there, x there. Remember, those technically become the number 1, right? When you divide out common factors, it's dividing something by itself, which would make the number 1. So I divide out the factors of x from the numerator and denominator, and what I'm left with, the only factor left in the numerator is 2 divided by, and the only factor left in the denominator is x minus 2. And since, you can put parentheses around it, but since it's the only factor left, and I'm done simplifying, I'm done dividing out, you don't need the parentheses around it. Great. So and that's I'm almost done. Sorry, I'm going to be folding this up so we can put it with see it with the original. So this is what we got: 2 divided by x minus 2. is 3 over x minus the quantity 1 over x minus 2 minus 6 over x squared minus 2x. This fraction minus the difference between these two fractions will have the same value as this fraction here, but not all the time. And again, you cannot plug in values for x that give you a factor of 0 in the denominators. You can never divide by 0, have 0 denominator, whatever. That's an undefined operation. So after I'm done here, I like to put off to the side, yeah, this original expression will be equal to this expression here that we got, as long as I don't plug in, right, as long as x is not, and then look throughout the problem. There were factors of x in the denominators throughout this problem. So I cannot replace x with the number 0. Alright, because if I do that, this will be 3 divided by 0. That's already no good. Right? You'd have 6 divided by 0 there. Negative 6 divided by 0 here. You're dividing by 0 in lots of places throughout the problem when x is 0. So x cannot be 0. And the only other factor I've noticed, you look through the entire problem we've worked out, this here and this here, right? Look through the entire problem. The only other factor I have seen in the denominator is this factor of x minus 2. There's x minus 2 there. So x cannot be replaced with the number positive 2, right? Because if x were replaced with 2, 2 minus 2 is 0. You'd have zeros in all these denominators all over the place, and that's not good. So here we go. So, and that's it. This is our final result. Alright, the value of my original expression will be equal to the value of this expression here, as long as I don't replace x with 0 and 2. Alright, now let's try that out. Let me test it out with some number here. Do it down here. How about I replace x with 3? Right, that's not 0 or 2. And do whatever you want, as long as it's not 0 or 2. So let's go back to the original. I'd have 3 divided by 3, which is 1, minus, and then the quantity, and then 1 divided by, x is replaced by 3, right? 3 minus 2 in the denominator would be 1. 1 divided by 1 is 1. And then minus, and then 6 divided by 9, right? 3 squared minus 6. 9 minus 6 would be 3. 6 divided by 3 is 2. So I'm getting 1 minus, 1 minus 2 is negative 1, and 1 minus negative 1 would be 1 plus 1. This has a value of 2. Right? So my original expression has a value of 2 when x equals 3. Now look at this here. You'd have, you got 2 in the numerator, divided by, and then 3 minus 2 in the denominator. I'm replacing x with 3. Well, that's just 2 divided by 1, which is indeed 2. Right? The same value. And again, try it out with any other numbers you want, as long as it's not 0 or 2, and you should be good. The value of this expression should be equal to the value of this expression that we got at the end. Alright, and yeah, so that's it for today on that video, on that topic, adding and subtracting fractions with unlike denominators. Right, you first find the LCD, rewrite all the fractions with a common denominator with that LCD as the denominator, and then do your addition and subtraction, right? Where the denominator will not change when you add and subtract, and whatever that common denominator is stays the denominator throughout the problem. Just combine the numerators, right? Add and subtract the numerators. Okay. And just be aware too of, when are you dividing by 0, right? Don't ever do that. All right, and as always at the end of these I like to say, try your best to get material on your own first before looking for help. I find that it sticks better and people remember things better when they've taken the time to learn it on their own. Means more. So read through the problems, read through your material, the author's examples, maybe even try to work out the examples the author gives before you read how the author does it. See how that goes, and then maybe try, and then practice, of course, practice problems from backs of texts, backs of sections, and check your answers in the back of a text or worksheet or wherever you're given, and see how you're going there. And don't just give up after the first attempt or even the first couple. If after several attempts of a problem you're still not clicking, still not getting it, try reading through the section again, reading through the material again, because maybe something will click the second or even third time through reading it that didn't click the first time. But if after several read-throughs of the material and several attempts at problems you're still not getting it, still not clicking, it is not a sign of weakness whatsoever to go out looking for help. That is what other people are there for. Talk to your teachers, your tutors, friends of yours in the class, or someone else you know who's taken the class, has notes or something that can help you. Look for videos online. There are plenty of resources on the internet. Videos such as this one or other ones out there that are plenty better than this one, I promise you. And just keep at it, stay persistent, keep practicing, don't give up, and I know you'll get it. And also try to go in with a mindset that you're going to enjoy it. Because if you go into something thinking, oh, I hate this, I've always hated this, I hate this, I hate this, I hate this, guess what? You're going to hate it. And it's not going to be fun, and you're going to be bored. Try to get in that mindset of, hey, maybe I'll enjoy this time. Maybe this will be fun. And, it's amazing what that can do, just a little change in attitude toward your learning something. So good luck, have fun, and thank you very much for watching.